Welcome to Study Session 4, Operating Systems. Introduction. Having learned about hardware and software components, we want to learn about a special type of computer software known as system software or the operating system. The operating system is the chief software of the computer system. It is a software which serves as an interface between the computer and other application programs for the user. The operating system is responsible for managing the computer system's software and hardware resources in order to make the computer usable. There has been a lot of evolution in operating systems over the years, starting from the monitors to the simple batch processing systems and to the multi-programmed and time-sharing systems. Each generation of operating system comes with its own peculiarities. In this study session, therefore, you will learn about computer components, personal computer system, and basic input-output system. At the end of this study session, you should be able to 1. Define computer component. 2. Explain personal computer system. 3. Discuss basic input and output system. Computer component. A computer system can be divided into 4 components: the hardware, CPU, memory, input-output devices, and so on. The operating system, the system programs, word processors, spreadsheets, accounting software, compilers, the application programs. Operating systems. An operating system is a program that acts as an intermediary between a user of a computer and the computer hardware. The main functions of an operating system are: 1. The operating system is an interface between the user and the computer. It does the following: provides access to the utility programs such as editors, debuggers, etc. Starts the execution of the programs, provides low-level I/O routines to the user, controls access to the files, provides access functions of the resources and data from unauthorized users, detects errors such as memory error, device failure, arithmetic overflow, and so on, and provides error handling routines, collects performance statistics. 2. The operating system manages the resources of the system, controls and allocates resources. System resources are memory, CPU, I/O devices, and so on. Classes of operating system. The operating system, OS, can be considered as the most important program that runs a computer. Every general-purpose computer must have an operating system to provide a software platform on top of which other programs the application software can run. It is also the main control program of a computer that schedules tasks, manages storage, and handles communication with peripherals. The central module of an operating system is the kernel. It is a part of the operating system that loads first and it remains in main memory. Because it stays in memory, it is important for the kernel to be as small as possible while still providing all the essential services required by other parts of the operating system and applications. Typically, the kernel is responsible for memory management, process and task management, and disk management. In general, application software must be written to run on top of a particular operating system. Your choice of operating system, therefore, determines to a great extent the applications you can run. For PCs, the most popular operating systems are Windows, MS-DOS, Microsoft Disk Operating System, OS/2, but others are available such as Linux, BEOS. For large systems, the operating system has even greater responsibilities and powers. It is like a traffic call. It makes sure that different programs and users running at the same time do not interfere with each other. The operating system is also responsible for security, ensuring that unauthorized users do not access the system. From this point of view, Operating systems can be classified as follows. 1. Multi-user. Allows two or more users to run programs at the same time. Some operating systems permit hundreds or even thousands of concurrent users. Multiprocessing. Supports running a program on more than one CPU. 3. Multitasking. Allows more than one program to run concurrently. 4. Multithreading. Allows different parts of a single program to run concurrently. 5. Real-time. Real-time operating system responds to input instantly. General-purpose operating systems such as UOS and Unix are not real-time. An OS is a 16-bit operating system if it processes 16 bits of data at once. For example, DOS. On the other hand, Windows 98 and OS2 WAP are 32-bit operating systems because they can process 32 bits of data at once. A network operating system is an operating system which makes it possible for computers to be on a network and manages the different aspects of the network. Simple batch systems. In the simple batch system, the user prepares a job which consists of program, data, and some control information, submits it to the computer operator, and receives the output after the program is executed. The job is usually punched on cards, and the output is usually printed. To speed up processing, jobs with similar needs can be batched together and run as a group. Thus, the operator sorts the programs with similar requirements into batches, runs each batch, and sends the output to the programmer. Therefore, in a batch operating system, there is a lack of interaction between the user and the job while that job is executing. The operating system is always in memory, and its job is to transfer control automatically from one job to the next. As the I/O devices are slower than the speed of the CPU, the difference may be 3 orders of magnitude or more. The CPU is often idle. For using the system more efficiently, cards can be read from the card reader onto the disk. The operating system records their location on disk in a table. When a job requests the printer, the output is copied into a system buffer and is written to the disk. When the job is completed, the output is printed. This form of processing is called spooling, a simultaneous peripheral operation online. Spooling is also used for processing data at remote sites. The CPU sends the data via communication paths to a remote site, and the processing is done with no CPU intervention. The CPU just needs to be notified when the processing is completed so that it can spool the next batch of data. Spooling overlaps the I/O of one job with the computation of other jobs. During the execution of one job, the spooler may be reading the input of another job while printing the output of a different job. Multi-programmed batch systems. Spooling provides a job pool on disk in order to increase CPU utilization. Jobs in the pool may be scheduled in different ways, such as first come, first served, shortest job first, priority basis, and so on. The most important aspect of job scheduling is the ability to multi-program. The operating system keeps several jobs, subset of jobs, in the job pool in memory at a time. During the execution of one job, if it waits for an I/O operation to complete, the operating system switches to and executes another job. In this way, as long as there is always some job to execute, the CPU will never be idle. Time-sharing systems. In multiple programmed batch systems, the user cannot interact with the program during its execution. In time-sharing or multiple tasking systems, multiple jobs are executed by the CPU switching between them, but the switching occurs so frequently that the user may interact with each program while it is running. Time-sharing operating systems. Personal computer system uses CPU schedules and multiprogramming, uses time slice mechanism, allows interactive I/O, allows many users to share the computer simultaneously. A computer system dedicated to a single user is referred to as a personal computer or PC. In the first pieces, the operating system was neither multi-user nor multitasking. The operating system concept used in mainframes and microcomputers today are also used in PCs. For example, Unix, Microsoft Windows, NT, Macintosh OS. Personal computer systems. Parallel systems have more than one processor. In multiprocessor systems, highly coupled, processors are in close communication, such as they share computer bus, clock, memory, or peripherals. Distributed systems also have more than one processor. Each processor has its local memory. Processors communicate through communication lines, for example, telephone lines, high-speed bus, etc. Processors are referred to as sites, nodes, computers, depending on the context in which they are mentioned. Multi-computer systems are loosely coupled. Example applications are email, web server, and so on. Real-time systems are special-purpose operating systems. They are used when there are rigid time requirements on the operation of a processor or the flow of data, and thus it is often used as a control device in a dedicated application, e.g., fuel injection systems, weapon systems, industrial control systems. It is well defined, fixed time constraints. The processing must be done within the defined constraints or the system fails. Two types. Hard real-time systems guarantee that critical tasks complete on time. In soft real-time systems, a critical real-time task gets priority over other tasks, and the task retains a priority until it completes. User interfaces for operating systems include simple command language, a menu, graphical representation of programs and data, I/O routines, service routines. Operating system features: bootstrap program, initializes CPU, loads OS kernel into memory. OS waits for events signaled by an interrupt either from a hardware or software. System call, monitor call, interrupt vector. Dual mode of operation: user mode, kernel mode, supervisor mode. Hardware protection: base limit registers. How a call can be made: user program run in user mode, operating system runs in kernel mode. BIOS, Basic Input Operating System. The BIOS is an interface between the operating system and hardware, changes from one computer to another, transfers a single character to printer, reads a sector from disk BIOS routine of CPM. Boot, reader, wboot, cell DSK, con out, list, read, punch, write. Process scheduling. The CPU is assigned to processes tasks by the operating system. In a multi-programming system, process scheduling is the management of the CPU by switching control among the various processes according to some scheduling policy. Memory management. Real memory is divided into partitions. Each process is assigned to a different partition. Fixed partitions, variable partitions, relocatable partitions. Virtual memory. In a virtual memory system, user programs are allowed to use a large continuous virtual address space, virtual memory, which may be even larger than the total amount of the real memory available. Portions of the virtual memory are mapped to the real memory as they are needed by the program. Demand paging is one of the mapping methods. This mapping process is completely invisible to the user. File management. File management functions of an operating system is an intermediate stage between the user program and the I/O supervision. Job scheduling. Job scheduling is the task of selecting the next user job to begin execution. In a multi-programming environment, job scheduler specifies the order of job execution. Resource allocation. The resources such as CPU, memory, I/O channels are needed by all user jobs, and their allocation is handled automatically by the operating system. Some problems to be handled by the operating system are mutual exclusion, process synchronization, deadlock avoidance, security and protection. Study session summary. In this study session, you have learned 1. Computer components. A computer system can be divided into 4 components: the hardware, CPU, memory, input-output devices, the operating system, the system programs, word processors, spreadsheets, accounting softwares, compilers, the application programs. Two, personal computer systems. A computer system dedicated to a single user is referred to as personal computer or PC. In the first species, the operating system was neither multi-user nor multitasking, e.g. MS-DOS. The operating system concepts used in mainframes and many computers today are also used in PCs, e.g. Unix, Microsoft Windows, NT, Macintosh OS. 3. Basic input-output system. It is an interface between the operating system and hardware. Changes from one computer to another. End of study session 4. Thanks for listening.